In this video, we are going to discuss MCQs from sets, relations and functions. In the previous videos, we have discussed the theory part of sets, relations and functions. Now we are going to work out MCQs based on that. The first question, if A is equal to set of ordered pairs x comma y equal to e raised to x, and B is set of ordered pair y equal to e raised to minus x. The question is, number of terms in A intersection B. Number of terms in A intersection B. How many elements are common for A and B? So, A and B contain set of ordered pairs. You give a number, the image must be same. For example, that means e raised to x. The first one's image is e raised to x. Second one, it is e raised to minus x. Both must be equal. When you give some value for x, both e raised to x and e raised to minus x must be same. Suppose you give 1, e raised to 1 and e raised to minus 1, they are different. Any value you give, they are all different except for 0. When you put x is equal to 0, e raised to 0 is 1, e raised to minus 0 is also 1. Only in that particular case, both the answers are same. So, number of elements common for A intersection B is only 1. So, the correct option is the third one, it is 1. Now let us see the next question. A equal to set of ordered pair xy, y equal to sin x, and B is set of ordered pair xy, y equal to cos x. Again the question is number of elements in A intersection B. Same method you apply, images are same we give, so sin x is equal to cos x. Bring that cos x down, so sin x by cos x, sin x by cos x. It is 1, so tan x is 1. Tan x equal to 1. You know, trigonometric function contains infinite number of solutions. Tan theta equal to tan alpha, you know how to solve that one. So, it has infinite number of solutions. So, the correct answer is the second one, infinitely many solutions. Now, let us see the third question. The relation R defined on a set A equal to 0, minus 1, 1, 2. X is related to Y if modulus x square plus y square less than or equal to 2. We can say x is related to y. The condition is modulus x square plus y square less than or equal to 2. Then which one of the following is true? See, the first one, the R is a relation they given like this. So you substitute and check whether all these elements satisfy this condition. All these elements satisfy, but if you see this one, 1 comma 2, if you put 1 and 2, 1 square, 1 plus 2 square, 4, you are getting 5. 5 is less than or equal to 2, that is not possible, so it won't come. Next one they said R inverse is, in R itself many elements are missing there, right? Even 1, 1 you can give, so definitely R inverse it won't come. And the domain of R, it is not A. So A is a set, that's all. Domain of R means in the relation, the first elements you take. In the first element, definitely 2 cannot come. If I take 2, it won't satisfy this because 2 square is 4. 4 plus any number, you won't get less than 2. So that also not possible. Domain of R is only 0, minus 1 and 1 should come. So range of R is 0, minus 1, 1 and that is the correct option. Question number 4. If f of x is modulus x minus 2 plus modulus x plus 2, then these are the 4 options given. So modulus function, be very careful, just remember this one value, modulus x is same as x itself if x is positive, and we take it as minus x if x is negative. So modulus x has 2 values, it is x itself if it is positive, minus x if x is negative. So now listen here, we have 2 modulus values here. One is modulus x minus 2, modulus x minus 2 I am taking it as A, and modulus x plus 2 I am taking it as B. We have to add them to get f of x. So f of x is A plus B. So what is A here? Modulus x minus 2. So what are the break points here? One is 2, another one is minus 2. So in a number line, I am taking minus 2 and plus 2. Now in each interval we see whether A is positive or B is positive or negative, we are going to see. You take the first value A. It is modulus x minus 2. You know, modulus x minus 2 is x minus 2 itself if x is positive. That is, if x minus 2 is positive. X minus 2 positive means x is greater than 2. X is greater than 2. So when is x is greater than 2, that is x is greater than 2 means in the last interval it is x minus 2 itself. A value x minus 2. In other cases it is minus of x minus 2. Minus of x minus 2 means minus x plus 2. Here also minus x plus 2. So this is the value of A. Now let us see B. B is modulus x plus 2. Modulus x plus 2 is x plus 2 itself if x plus 2 is positive or x is greater than minus 2. So when x is greater than minus 2, greater than minus 2 is here, greater than minus 2 means its right side. Its right side, the value is x minus 2 itself. So here it is x minus 2, sorry, x plus 2, here it is x plus 2, here also x plus 2. In the other interval, minus of x plus 2, that is minus x minus 2. These are the values of A and B in all the three intervals. Now fx means you have to add it. A and B add to get f of x. If you add the first case, you are getting minus 2x, second case you are getting 4, and the third case you are getting 2x. Now we see which option is the correct one. The first one is it is minus 2x, second one it is 4, and the third one it is 2x. Minus 2x, 4, 2x. The first option is the correct one. Question number 5. Let R be the set of all real numbers. Consider the following subset of the plane. The first one, S. S is set of all ordered pair and y is equal to x plus 1. X lies between 0 and 2. And the second one, T, again ordered pair xy. It is related when x minus y is an integer. See the options. T is equivalence, S is not equivalence. S and T are not equivalence. Both S and T are equivalence. S is, so we have to check whether it is equivalence relation or not. So you must know what is equivalence relation. What is equivalence relation? It must be reflexive, symmetric and transitive. If all the three conditions are satisfied, then we say it is equivalence relation. You take the first one. S is, we have to check whether S and T are equivalence or not. If any one of the property not satisfied, it is not equivalence, right? So first you start with reflexive relation. You take an element, so x lies between 0 and 2. For example, you take 1. What is reflexive? Every element related to itself. So you can check whether 1 comma 1 belongs to S. If you put x equal to 1, you have to get y also 1. Then only we say it is reflexive. When you put x equal to 1, will you get y1? No, y is equal to 1 plus 1, it is 2. So it is not reflexive. When you put x equal to 1, you have to get y also 1. It is not reflexive. It is not reflexive means it is not an equivalence relation. No need to check other. It is not equivalence relation. Now we go for T. Set of all xy such that x minus y is an integer. X minus y is an integer. Integer means 0, positive values, negative values, right? 0, 1, 2, 3, minus 1, minus 2, minus 3, etc. X minus y is an integer. So, reflexive check, you take two integers. So, for example, 5 and 5. 5 minus 5, it is 0, it is an integer. Minus 2, minus 2. So, minus 2 minus minus 2. So, minus 2 minus 2, it is 0, 0 is an integer. So, any two integers you substitute, you will get it satisfies what? Reflexive relation. Symmetric you check, x minus y is an integer, then you find y minus x. X minus y is an integer, then y minus x is also an integer. It changes the sign, again it is an integer, so it satisfies symmetric. So it is reflexive and symmetric. Now we check for transitive. X minus y is an integer and y minus z is an integer. X minus y is an integer, y minus z is an integer. Definitely x minus z is also an integer, so it is transitive also. So in T, all the three conditions satisfy: reflexive, symmetry and transitive. So T is equivalence. S is not equivalence, T is equivalence. See which one is the correct option? The first one. T is an equivalence relation, but S is not an equivalence relation. Question number 6. Let A and B be subsets of the universal set. A and B are subsets of universal set N. A and B are subsets of the universal set n. So here the universal set is n, set of natural numbers. Then then A dash union A intersection B union B dash. It looks little lengthy one, but you can do it very easily. Look here. First all union only, right? A union A intersection B union B dash. Now let us see A dash. What is A dash? Outside A, everything you can take, right? Outside A. So this is A dash. Union, with this you are going to add something. What you are adding? You are adding A intersection B. That means this also you are adding. Also union B dash. B is outside, fully you add. B is outside, so this also will come. So you are getting the entire set. That is, you are getting the entire set n. So the correct answer is the fourth option. Now let us go for the next question. The number of students who take both the subjects mathematics and chemistry is 70. Mathematics and chemistry is 70. And this 70 is 10% of enrollment in mathematics. This 70 is 10% of those who enrolled in mathematics. So if you simplify, for mathematics it is 70 into 10, 700. Mathematics it is 700, already we have written 70. So 700 minus 70, it is 630 here. And the same 70 is 14% of the enrollment in chemistry. That same 70 is 14% of those who enrolled in chemistry. So here if you cancel, C is equal to 70 into 100 by 14. If you simplify, you are getting 5 times. So you are getting 500. Already 70 are written, so the balance is 430. What is the question? What they asked? Number of students take at least one of these two. At least one of these means you have to add all the three. 630 plus 70, it is 700 plus 430. So the answer is 1130. So second option is the correct one. N of A cross B intersection A cross C. Just to remember this. N of A cross B is same as N of A into N of B. So using this only we can do this one. So what is given here? N of A cross B intersection A cross C, they given us what? 8. You can split into 2. N of, or you can write like this, N of A cross B intersection C equal to 8. Because A cross B intersection C is A cross B intersection A cross C. Now we can write it as N of A into N of B intersection C is equal to 8. N of A, that's what we want to find. N of B intersection C given as 2 equal to 8. So N of A is equal to 8 by 2. So the answer is 4. So the correct option is 2. See the ninth question, very similar question. N of A is 2, N of B union C is 3. What they asked to find? Number of elements in A cross B union A cross C. Again this can be written as N of A cross B union C. C expand and C, A cross B union A cross C. So you can write like this. Now this can be written as N of A into N of B union C. N of A is given as 2. N of B union C is 3. So 2 into 3, the answer is 6. So the correct answer is what? The third option. Sum number 10. Two sets A and B have 17 elements in common. A and B. Number of elements common 17. Then the number of elements common to A cross B and B cross A. For A and B, the common elements are 17. From that you can form how many ordered pairs? It is 17 into 17. So that, because 17 is the common number of elements, so the number of elements common for both A cross B and B cross A is 17 into 17. So the answer is 17 square. So that is the 10th question. Now let us go for the next question. For non-empty set A is a subset of B. Then A cross B intersection B cross A is equal to. That is again intersection. Intersection means common elements. The previous question is common element 17. So the answer is 17 into 17. So here A is a subset of B, A cross B, A is a subset of B. So number of elements common is number of elements in A. So A cross B intersection B cross A is A cross A. A cross A is the correct answer. Now let us go for the next question, number 12. This is a very important question. They can frame number of questions. So I'll explain all the theory part clearly, so listen carefully. The question is number of relations on a set containing 3 elements. But listen, these 4 points you have to remember. Suppose n elements are given. Suppose n elements are given, then how many relations you can form? 2 raised to n square relations you can form. Number in which how many of them are reflexive? The formula is 2 raised to n square minus n. Number of symmetric relations. If n elements are given, number of symmetric relations, it is 2 raised to n square plus n by 2 in the power you are right. And the number of reflexive and symmetric, it is 2 raised to n square minus n by 2. So you remember all the 4 results, but here they asked number of relations. So we have to use the first formula. If n elements are given, 2 raised to n square. Here 3 elements are given. So instead of n you put 3. 2 raised to 3 square. That is 2 raised to 3 square is 9. 2 raised to 9 is 512. So the correct option is the third one. Now we go for the next question. Question number 13. R be the universal relation. So you know there are 2 types of relations, empty relation and universal relation, called extreme relations. So R is a universal relation on a set X with more than 1 element, then R is. You know, universal relation is an equivalence relation. Universal relation is an equivalence relation. So it is reflexive, it is symmetry, and it is transitive. So equivalence relation, that option is not here. So what do you do? Give the best option. You know, it is reflexive, it is symmetric, it is transitive, it is equivalence. So among these 4, not reflexive, you cannot take it. Not symmetry, you cannot take it. Transitive, yes, it is transitive. And another one is none of these. Suppose if an option is equivalence relation, we take that one. But among these 4 relations, the best option is, it is transitive. So we select the third option. Now we go for question number 14. Now listen this one. X is given as 1, 2, 3, 4. A relation is given. Now they asked whether this relation is reflexive, symmetric, transitive. If all the 3 satisfied, we say it is an equivalence relation. First we check for reflexive. Reflexive means every element must be related to itself. 1 must be related to 1, yes. 2 is related to 2, yes. 3 is related to 3, yes. 4 must be related to 4. 4, it is not there. So it is not reflexive. If it is not reflexive, definitely it won't be equivalence. So now only the other 2 you have to check. You check whether it is symmetric. Symmetric means what? If A is related to B, then B also must be related to A. 1 is related to 2, so 2 is related to 1. 1 is related to 3, 3 is related to 1. 1 is related to 4, 4 is related, everything satisfied. So it is symmetric. So this could be the answer. Now check for transitive also. Transitive means what? If A is related to B and B is related to C, then A must be related to C. In some cases it's satisfied, but it must be true for all these elements what is given in R. I am taking this one 4, 1. 4, 1, that is 4 is related to 1, and 1, 3, that is 1 is related to 3. 4 is related to 1 and 1 is related to 3. So if it is transitive, 4 must be related to 3. 4 must be related to 3. But 4, 3 is not there. So even one example is enough, it is not transitive. So the correct option is symmetric. So the second option. Okay. Now let us go for the next question, sum number 15. The range of the function. The range of the function 1 by 1 minus 2 sin x. You do it very carefully. So before that you have to remember one thing. When the inequality reverses, you know 2 is less than 4. While adding a number on both sides or multiplying by a positive number, it won't change. The inequality reverses in 2 cases. Suppose I am changing the sign, that is I am multiplying by minus 1. So what happens? This become minus 2 and this become minus 4. You know minus 2 is greater than minus 4. And in another case, if we take reciprocal, 2's reciprocal 1 by 2, 4 reciprocal 1 by 4, again 1 by 2 is greater than 1 by 4. Only in these two cases the inequality reverses. In one, when you multiply or divide by a negative number, and in another case when you take reciprocal. So with this idea, let us see this sum. We start from the basic, sin x. Sin and cos always lies between -1 and +1. -1 less than or equal to sin x, less than or equal to 1. So sin x lies between -1 and +1. Next we need 2 sin x. So multiply every term by 2. So you get -2 less than or equal to 2 sin x less than or equal to 2. You are multiplying by a positive number, so no change. Now minus of this. So we are changing the sign. You are changing the sign throughout. When you change the sign, the inequality reverses. Less than or equal to become greater than or equal to. Change the sign, 2. Greater than or equal to -2 sin x. Greater than or equal to -2. Now we need a 1. So adding 1 with every term. Adding 1. If we add 1, this becomes 3. Greater than or equal to 1 minus 2 sin x. Greater than or equal to, we are adding 1, you get -1. Now 1 by, you take reciprocal. When you take reciprocal, again the inequality reverses. So 1 by 3. Inequality reverses, it becomes less than or equal to 1 by 1 minus 2 sin x less than or equal to, reciprocal of -1 is -1 itself. So this is our fx. So you are getting 1 by 3 less than or equal to f of x less than or equal to -1. If you split into 2, f of x is greater than or equal to 1 by 3. F of x is greater than or equal to 1 by 3, and f of x is less than or equal to, f of x is less than or equal to -1. -1 less than or equal to -1, this area. That is -infinity to -1. And another one greater than or equal to 1 by 3, greater than or equal to 1 by 3, greater than or equal to 1 by 3, this portion. So 1 by 3, 1 by 3 comma infinity. So these are the ranges will come. So the correct answer is -infinity to -1. -1 is included, 1 by 3 to infinity. So the correct answer is the fourth one. So that is question number 15. Now we go for the next question, question number 16. In this question, the range of the function they asked, the range of the function f of x equal to greatest integer function x minus x. Greatest integer function means you take the left side element. Suppose it is 1.5. So in the number line, 0, 1, 2, 1.5 is here, left side number is what? 1. You substitute some number and check, because anyhow finally you are taking the modulus of greatest integer of x minus x. When you take modulus value, definitely there won't be any negative number, so the answer may be 0. Suppose if I give 1, here greatest integer of 1 is 1 and this is 1, 1 minus 1 is 0. So answer can be 0, 0 is included, so 0 is included, right? So that won't come. Give some other value, for example I am giving 2.3. If I give 2.3 modulus, greatest integer of 2.3 is 2. So 2 minus 2.3. So the answer is minus 0.3. Take modulus value, it is 0.3. So the answer can be 0. It can be 0.3. So suppose I am giving say 2.9. I am giving, what you will get? This is 2 minus 2.9. When you take modulus, it is 0.9. 0.9. It won't be 1. It will be very closer to 1, but it will not be 1. So the correct answer is 0 to 1. 0 is included, but it won't be 1, slightly more than 1, slightly before 1. So the correct answer is 0, 1, and the 1 is the open interval. So the correct answer is the third option. The rule f of x equal to x square is a bijection. What is bijection? It is 1, 1 and on 2. Then the domain and codomain are given by. So f of x equal to x square. You have to remember f of x equal to x square. Suppose if I give 4, if I give say 2, it is 2 square. 2 square is 4. If I give -2 square is also 4. Inverse exists means it won't be what? 1, 1. So inverse exists, or you say it is a bijection, it cannot be like this, so you can't give all these negative values. Then when if it is many 1, inverse won't exist. So it must be 1, 1. So you cannot take the negative values. 0 to infinity only you can give. So the domain is 0, infinity, and the Codomain is also 0, infinity. So the correct option is the fourth one. Now let us go for question number 18. Number of constant functions from a set containing m elements. The first set there are m elements. To the set containing n elements. Here there are n elements. For example, here there are 3 elements. Listen, assume there are 3 elements. How many constant functions you can form? Constant function is every element related to a single element. So you can form a function like this, right? S, it is a constant function. Or you can relate every element with what? B, constant function. Or you can relate every element with what? C. You can frame 3 constant functions. If there are 3 elements, you can form 3 constant functions. There are n elements in the codomain, so you can form n constant functions. So the correct answer is 3. Now let us go for the 19th question. The function 0, 2 pi minus 1 to 1 defined by f of x is equal to sin x. F of x is equal to sin x. The function is 0 to 2 pi. You know what is sine function? Sin 0, 0. Sin 90 is 1. Sin 180 is 0. Sin 270 is minus 1. Minus 1. And sin 2 pi is again 0. So if you draw sine curve, it will be like this. So this is the sine curve. 0 to 2 pi. The minus 1 to plus 1 value, right? Now this function is 1 to 1 on to bijection and cannot be defined. This is what they asked. So what you do here, horizontal line test you can use. Already it is a function. To check whether it is a function or not, we use vertical line test, right? Function is given. To check whether it is 1, 1 or on to or not, we have to use horizontal line test. When you draw a horizontal line, if it cut more than one place, if it is not cutting the curve, we say it is not onto, it cuts the curve, right? Any point you draw a horizontal line, it cuts. So it is onto function. It is onto function. So the correct answer is onto. Now let us go for the next one, question number 20. The function minus f from minus 3 to 3. Minus 3 to 3. From minus 3 to 3 defined by f of x equal to x square. F of x equal to x square. Minus 3. So when x square is given, so when you find the image, everything will be positive because x square, minus 3 square, it is 9, right? Minus 3 square is 9, 3 square is 9, 0 square is 0, 0 square is 0, 1 square is 1, 0, 1, 2, etc. up to maximum it will be what? 9. Here 0, 1, 2, 3, minus 1, minus 2. So the images will be only from 0 to 9. So the correct answer is 4 because the function is f of x equal to x square. When you square it, the answers are all positive. So maximum value 3 and the minimum value minus 3, its square also what? 9 only. So it takes the values only from 0 to 9. So the correct answer is the fourth one. Now let us see the next question. Question number 21. X is 1, 2, 3, 4. X is 1, 2, 3, 4 and y is a, b, c, d. 1 is related to a, 4 is related to b, 4 is related to b, 2 is related to c, 3 is related to D, again 2 is related to D, 2 is related to D. The element 2 has 2 images, so it is not a function. So the correct answer is the fourth one because the element 2 has 2 images. Now let us see the next question. Question number 22, inverse of fx. You have to be very careful in this question. Inverse of, you know how to find inverse. Let us see the second one, y equal to x square, y is equal to x square. How can you find the inverse of this function? So you take this as what? Y. So y square equal to x or y is equal to what? Root x. So this is the inverse. So inverse is root x for the second question. For the first one, y equal to x. So it is same as, so same image only. So it is x only for that one. For the first one, the inverse is x. For the second one, it is root x. And the last one, you see, y is equal to 8 root x. So here 8 you bring here, so y by 8, that is root x. If you square it, x is equal to y square by 64. So this is the inverse. When you write f inverse of x, this is actually f inverse of y, right? F inverse of x means it is x square by 64, x square by 64. These are the three values. So the first one it should be x, second one root x, and the third one x square by 64. The first option x root x, x square by 64. So first one is the correct option. Now let us go for question number 23. F of x is defined as 1 minus modulus x, 1 minus modulus x. You substitute some values and check. For example, if you put 0, modulus x cannot be negative, right? It is a positive one. If you put x is equal to 0, what is f of x? 1 minus 0. So the answer is what? 1. So it can be 1. Suppose I am giving x is equal to say 2.5. What will happen? 1 minus modulus 2.5, it is 2.5. So the answer is minus 2.5, right? Sorry, minus 1.5. You are getting minus 1.5. Any number you give, maximum it can be 1 or it is less than 1. Less than 1 means it can go up to minus infinity. So the correct option is minus infinity comma 1. Now let us go for the next question, sum number 24. The function f of x is defined like this, sin x plus cos x. F of x is sin x plus cos x. We have to check the f of x is odd or even. You know what is odd function, even function. You find f of minus x. If it is f of x itself, we say it is even. If it is minus fx, the function is what? Odd. So here, you know sin x is an odd function. Sin x is an odd function. Cos x is an even function. In between we have the sign plus. If it is multiplication, okay, minus into plus, it is minus, you can say it is an odd function. When plus comes, you cannot say it is odd or even. So it is neither odd nor even. Okay, sin is an odd function, cos is even function, but sin x plus cos x. Suppose if they say sin square x, sin is an odd function. When you square, it becomes plus. It is even function. But sin x plus cos x, it is neither odd nor even. Question number 25. The function f from R to R is defined by, a lengthy function is given, but it's a very simple one. Here also you have to check whether the function is odd or even. The method is for x you put minus x. See the first term, for x you give minus x, there is no change. Cos x is an even function, so this is even. Second factor you see 1 positive, x raised to 4. That is also even function. If you give minus x, there is no change. So totally this is also an even function. See the denominator, x you give x, it is an odd function because when you change the sign minus x, right? Then second one is sin x, that is also odd function. Odd function minus odd function. So totally it is an odd function. And the last one is see 2x. 2 into x, right? X when you change the sign it is minus x, odd function. X cube minus x the whole cube, negative. So that is also odd function. So among the 4 factors, 2 of them are positive, 2 of them negative. Minus into minus is plus. So the final answer is it is an even function. So that's all the objective questions from the first chapter. So next video we'll discuss about the second chapter. Thank you.